Today we will talk about the field effect transistor of electronic components. Field effect transistor is also called MOSFET. Its alphabet is also represented by Q or PQ like the transistor. It is divided into two categories. Which two categories? The first one is N-channel. Its symbol on the circuit diagram is like this. It has three poles, namely D pole, G pole, and S pole. There is also a P-channel. Two kinds of channel. The circuit symbol of these two kinds of channels are different. Everyone, the arrow pointing to the G pole inside is the N channel. The arrow pointing to the S pole is the P channel. We must not confuse these two channels in the circuit diagram in the future. The D pole called drain, S pole called source. G pole is called gate or control pole. The two channels have the same appearance and function, but they are not interchangeable. Because they work differently. Its main function is to act as a switch. So how many appearances does a field effect transistor have on the actual circuit board? In appearance, one is 3-pin. It looks very similar to transistor in appearance. This is G pole, this is D pole, and this is S pole. It is the same on both Apple Mac and Windows laptop, and is more common. There is also a 6-pin. This is the first pin. This pin are D pole. 1, 2, 3, 4, 5, 6. That is 1, 2, 5, 6 corresponds to the D pole. Our third pin is our G pole. This is the pin is G pole. And the fourth pin is our S pole. We all have this kind of FET on our laptops. The third type is the 8-pin FET. Eight-pin field effect transistor is inside. This is the first pin, 2, 3, 4, 5, 6, 8. Then the three pins of 1, 2, 3 are connected, which is the S pole. 5, 6, 7, 8, these four pins are connected to the D pole. This independent pin is a G pole. We call this kind of tube a signal tube. There is only one FET. There is another kind of we call the double tube. Then these two pins are connected to the depot. What about these two pins? This is the S pole, this is the D pole. There is two field effect transistors. And this is our D pole. Then this is S pole, then this is G pole. It is in this shape. This is called double tube. Two field effect transistors are integrated inside. And the field effect transistor on the laptop is relatively easy to break. Wait a minute. We'll take everyone to find this common field effect transistor on the side of the circuit and on the drawing. 3-pin, 6-pin, and 8-pin. And these types of tubes are divided into N-channel and P-channel. Specifically, whether it is N-channel or P-channel, we need to use a multimeter to measure. Or look at the drawing and see the arrow to identify. Arrow pointing to G pole is the N-channel. Arrow pointing to the S pole is P-channel. Then apart from looking at the drawing and measuring with a multimeter, how to measure the N-channel and P-channel? Let's wipe the whiteboard first. The so-called N-channel is measured with a multimeter. Set the universal tube to the diode position. For the N-channel, the red test lead is placed on the S pole, and the black test lead is placed on the D pole. It can measure around 300 to 800. For the P-channel, the red test lead is placed on the D pole, and the black test lead is placed on the S pole. Then the measured value is about 300 to 800. That is to say, if the N-channel and P-channel are measured with a multimeter, they will reach the diode position. Its two positions are different. In other words, if it is an N-channel, whether it is 6-pin, 8-pin, or 3-pin, the test method is the same. If it is N-channel, put the red test lead on the S pole and the black test lead on the D pole. If it can be measured about 300 to 800, it is N-channel. On the other hand, if it is said that the red test lead is placed on the D pole, the black test lead is placed on the S pole. The one that can be measured about 300 to 800 is the P-channel. Don't confuse these two channels. When we measure, you don't need to care it is 8-pin channel. If you want to put the red test lead on the D pole and the black test lead on the S pole, if it can be measured about 300 to 800, it is a P-channel. It doesn't matter whether it is an 8-pin or 6-pin. This is a measurement and judgment of the field effect transistor. But if the tube is broken, the value cannot be measured. the value can only be measured under good conditions. Conversely, if our red test lead and the black test lead can be measured, it means that the tool is broken. Find the same type of tool to replace it. So everyone must pay attention to this, because it is easier to break. Then the GPO does not participate in the measurement of good or bad. GPO is involved in the work on the circuit. It only plays a control role. So we had to figure out this point. Then we will find these few tools on the board. Okay, let's take a look at the 3-pin FET. The first pin is the G pole and the second pin is the S pole, both of which are grounded. The third pin is D pole. You can see that the arrow in there points to the G pole. This shows that this tube is an N-channel tube. It is used as a switch on the circuit diagram. This kind of field effect transistor is a 3-pin field effect transistor. Let's take a look at the second one, the 6-pin field effect transistor. So who is the arrow of the 6-pin field effect transistor pointing to? What is our fourth pin? The third pin is G pole and the fourth pin is S pole. According to this symbol, the independent pin is G pole. The fourth pin is S pole, which is fixed. Everyone should remember this corner firmly. And our 1, 2, 5, and 6 pins are connected. But what kind of form it is? Using the method of elimination is the D pole. In other words, I will make the 6-pin field effect transistor in the future. The fourth pin must be S pole, the third pin must be G pole. 1, 2, 5, and 6 pin must be connected, which is the D pole. This is an international standard. Let's not to make mistake. Let's take a look. Here is the arrow, and this is the dial. It integrates the dial inside. Point of our arrow, it points to the S pole. I just mentioned that the arrow points to the S pole, so it is a P channel. If the arrow points to the G pole, it is an N channel. The two cannot be confused. This kind of 6-pin tube is relatively easy to break. At the time, we only need to measure whether there is a value between the D pole and the S pole to know if the tube is damaged. So this point is a 6-pin field effect transistor. We'll also talk about the circuit behind. Okay, let's look at the third type is the 8-pin field effect transistor. Look at the circuit diagram. The 4th pin is the G pole, which is the control pole. And there are 3, 5, 6 pins are S pole. Everyone, take a look. There is an S written on it. And the 1, 2, 7, 8 pins are connected. Then it is the D pole. Let's take a look at the dial inside. What pole does the arrow pointing to? Since the arrow points to the G pole, what channel should it be? N channel. These 8 pins will be marked on the drawing. Even if there is no mark, if encountered this structure, its 4th pin must be G pole. The 3rd, 5th, and 6th pin are S poles. And 1, 1st, 2nd, 7th, 8 pin are D poles. Judge its channel by the arrow. So don't misjudge the point. If the arrow points to the S pole, it is a P channel. This is how the 3 field tubes are marked in the circuit diagram. We have to learn to distinguish. Okay, so let's talk about why the N channel and P channel can be interchanged. This is easy to confuse in the actual maintenance, because the working conditions required by the G pole are different. This is determined by the manufacturer when designing the FET. Our N channel requires that the voltage of G pole be greater than the voltage of the S pole, above 4.5 volt toward normal. And our P channel requires the voltage of G pole to less than the voltage of S pole, above 2.5 volt toward normal. This means that the essential reason why the two tubes cannot be interchanged is here. So we're repairing in the early stage why these two kinds of tubes cannot be interchanged. This is determined by its essence, not by you or me. Whether it's a 3-pin MOSFET, an 8-pin MOSFET, or 6-pin MOSFET, it follows the rule. So don't replace these two MOSFET by mistake during maintenance. Not to be confused with the transistor and replace it. Especially for this kind of 3-pin, there is a transistor or a FET. We have to judge according to the drawing. But for the 8-pin ones, the one marked with the Q or PQ must be the FET. Because there is no 8-pin transistor. The same is true for 6-pin ones. They all have more FET. We need Q and PQ, so we have to figure out this point. So let's first look at the application of these types of tools. The first application is called 3-pin FET. This is the first pin G pole, the second pin S pole, and the third pin D pole. So on the circuit diagram, it generally has one pin to ground. Most of them are N-channel. For N-channel, the arrow points to the G pole. When encountering this kind of filled tube, generally speaking, the G pole only needs to have a voltage greater than the 0.7 volt. This tube will work. The current flows from the D pole to the S pole. The arrow is only used to identify this channel use, not as a current flow judgment. This must be clear. Do not use the arrow to determine the direction of current flow. Our current flows from D pole to S pole. N channel, 3 pins. Will not flow to G pole. G pole only plays a role in controlling conduction. Whether it's 8 pins, 6 pins, or 3 pins, the G pole is only used for control. It is not used to judge the direction of the current flow. The arrow here is only used to judge the channel. This kind of pilot needs to be clear. This kind of tube, when you measure the D pole and the S pole, its value can be used to judge its quality, regardless of whether it is a diode, a FET, or transistor. The diode gear is used to test. Because there is a diode inside it, so I use the diode gear to measure. This point needs to be clarified. This is a 3-pin FET. It rarely goes to a P-channel, and most of them are N-channel or Mac. So we have to figure out this point. This is a 3-pin FET. The second type is a 6-pin FET. Generally speaking, there are more N-channel and there are also P-channels. Why? Here's like this. The third pin is our G pole. The fourth pin is our S pole. At first, second, fifth, sixth pin are depot. This kind of tube is generally used as a power switch. The arrow points to the G pole, which is also in the N channel. This kind of tube is used as a power switch. Control the voltage flow and current flow between the D pole, S pole by voltage of G pole. It is also through the voltage of G pole to control the input and the output relationship between the D pole and the S pole. In other words, under what circumstance? With the 6-pin FET, the voltage of the D pole is already equal to the S pole when it is working. Under normal working condition, Vd, the voltage of D pole, is equal to the Vs, the voltage of S pole. So the G pole, do you see whether it is N channel or P channel? If it is an N channel, its G pole is greater than Vd, the voltage of D pole, or Vs, the voltage of S pole, above 4.5 volts. If it is a P channel, its G pole is less than Vd, the voltage of D pole, or Vs, the voltage of S pole, and less than 2.5 volts or more. In other words, during maintenance, if the 6-pin fail control. The first type of power switch, if it is found that the voltage of D pole and the voltage of S pole are not equal, that means the circuit has a problem. How can we fix it while maintaining? Okay, we won't fix it or change it. Use a wire to connect these 2 pins with a jumper wire. You can jumper directly without removing it. Use a thick thread to jumper. In short, just connect the D pole and S pole directly. G pole only plays a control role. So we can solve the fault, but the circuit is not controlled. The fault is solved. This is a repair technique. The premise is that this kind of power switch has 6 pins. In other words, we are not on the circuit. 1, 2, 3, 4, 5, 6 pin. There is a dot here. Then the 4 pins are connected to the D pole. The 3rd pin is the G pole and the 4th pin is the S pole. If it is found that the voltage of D pole and S pole are not equal during maintenance, that means there is a problem with the circuit of the tube. It's to measure the voltage when it is energized. Normally, Vd is equal to Vs, that is, the voltage of D pole and the S pole are equal. If the 2 pins are not equal when charging, that means this circuit is damaged. It is possible that the G pole has no voltage, but we use a wire to shock jumper the D pole and the S pole for maintenance. This is a technique and method. I hope you can use it for reference in maintenance. Okay, this is the 6-pin FET. But the 6-pin FET is not used much on the circuit board, but it will exist. Once it exists, everyone must focus on checking. It is also relatively easy to break. If you can find the corresponding board or components to exchange, you can only short jumper the D pole and the S pole. Never connect it to the G pole because it is connected to the IC and control it. Okay, this is our 6-pin FET. Okay, let's talk about the application of the 8-pin FET, which is the 3rd FET. The first type to be used as a level-to-level power switch. What is level to level? When working, the voltage of D pole and the voltage of S pole are always equal. Therefore, the level to level voltage will increase, but the input and output voltage will always be the same. It will be marked in the circuit diagram. For example, if you see a circuit diagram, an 8-pin FET. The 4-pin is G pole. The first, second, third pin are S pole. The 5th, 6th, 7th, 8th pin is D pole. In the circuit diagram, 1, 2, 3 pins are S pole, and 5, 6, 7, 8 pins are D poles. Then when working, the voltage is always equal. If there is 5 volt there, it should be 5 volt here too. Why is it called level to level? When it is working, the voltage at both ends are equal. Then the voltage of the G pole is the same, which is similar to the principle of the 6 pins. In other words, it depends on whether it is an N-channel or P-channel. If it is N-channel, how many volts should the G pole be greater than the S pole? The voltage of G pole is higher than the voltage of S pole by more than 4.5 volt, so the voltage of G pole of N-channel should more than 9.5 volt. What if it is a P-channel? Of course, the N-channel is, for example. If the arrow is outward, that is a P-channel. How many volts should the G pole be smaller than the S pole? Because the voltage of G pole is lower than the voltage of S pole by more than 2.5 volt, so the voltage of G pole of N-channel should be lower than 2.5 volt. The key to see was structure. Therefore, most of the circuit diagrams are N-channel. There are many such large-scale N-channels. Next, point out the working circuit of the channel on the circuit diagram. So the initial voltage are equal. So this is called level to level. So if you encounter this kind of circuit during maintenance, the voltage of D pole and S pole are not equal. Doesn't match the mark on the circuit diagram. That means that the two circuit has also been damaged. You can also sharp jumper, connect the D pole and S pole with a jumper wire. This is a speculative method, a creep method. This kind of 8-pin power switch is also widely used. Which circuits will be used on the notebook? The power supply of those interfaces will be used here, such as hard disk, screen, USB, fan, etc. The power supply on this connector is turned over through this level to level. Via pairing, if your screen is not bright or does not display, or the USB port cannot be used, it has a corresponding level to level FET tool for switching application. So this point is the most important thing. I will show you this kind of power supply that is level to level power on circuit diagram. This is the first way of working, the principle of the level to level. There are more applications and it is easy to break. This should be clear. The second application of the 8-pin FET is connected to the large inductor for high side and low side MOSFET. Form a PWM power supply circuit. The 8-pin FET is probably like this. Five, 6, 7, 8 is connected to the D pole. This 4th pin is our G pole. The bottom 3 pins are 1, 2, 3, that is S pole. It also has more N channel. You can take a look at this picture. What will the S pole and the high side MOSFET connect? Both of these are N-channel, the fourth pin is G-pole. Then the large inductor is connected here, the inductor coil. It is L or PL. Let's take a look at this 8-pin FET tube. This is a power supply chip. This kind of circuit is quite common in laptops. The power of the 8-pin FET tube is relatively large. It relates on the high side MOSFET. The S pole of the high side MOSFET is connected to D pole to the lower side MOSFET. The S pole of the lower side MOSFET is connected to the ground. The inductor is charged and discharged through the on and off of these two tubes. This electricity can load. When working, the chip output is a square wave. Use an oscilloscope to measure. It is a square wave. The two FET tubes are turned on in turn. The high side MOSFET is turned on to charge the inductor, and the lower side MOSFET is turned on to discharge the load. Our load component draws electricity power from the inductor. These two FET tubes control the charging and discharging of the inductor. And our chip uses this square wave to control the two 8-pin FET tubes in turn. This kind of circuit is also relatively easy to break. We call the grounded tube the lower side MOSFET, and the ungrounded tube the higher side MOSFET. This chip is called the power supply chip, also called the PWM chip. Which circuits we will talk about later? We will talk about the CPU power supply circuit later. 3-volt, 5-volt standby circuit, as well as charging circuit, including memory power supply circuit. The power supply of the bridge, PCH, and the power supply of our graphics card. These power supplies use the power supply method uniformly. Because of the structured power supply mode, it generates enough power. It supplies power to this device with relatively high power consumption. The power consumption of this device on the laptop is relatively large. Only use this way to power it. In order to work stably with these loads and equipment. We will talk about this kind of circuit later. After learning this method in place, the capacitors on back can be repaired and tested easily. When we open the circuit diagram, we will take everyone to find these power supply methods. This is a third power supply method to work as both high side and low side MOSFET. At present, only this method can be used by FET. We're combining the circuit board and circuit diagram to analyze and find. It can be used in maintenance. How to check the detail? We will talk about it in detail later. The above is the FET application. Okay, let's take a look at this level-to-level power supply. Let's take a look at these 3 pins of S pole, 1, 2, 3. Its G pole is here, and the 4th pin controls the pole. It is N-channel. Why is it called level-to-level? Everyone take a look. What do these 5 pins mean? Actually, it is an 8-pin FET chip. It connects the pin of 5, 6, 7, 8 to 1 pin. So we just mentioned that the 8-pin FET tube has 5, 6, 7, 8 pin. Why is it not marked? In fact, it is 5, 6, 7, 8 pin, and it is called 5 pins when connected together. 5 pin, this point needs to be clarified. Why is this power supply called level-to-level? Because the voltage of D pole and S pole are equal. 5 volt is marked on the drawing. In other words, when we're pairing like this, the input is 5 volt and the output is still 5 volt. Its voltage is equal. If during maintenance, if the voltage of D pole and S pole is not equal. So what should I do if the circuit of the FET tube has been damaged? We can short jumper the D pole and S pole with a wire. This is the first application of the 8-pin FET tube level-to-level. Damage to the G pole will also cause it not work. P-channel, G pole should be less than S pole 2.5 volt or more. If you really want to fix it, you can fix it. It's just that during maintenance, most maintenance masters are unwilling to complicate it. In other words, connect the D pole and S pole in this convenient way. So when we are repairing in the future, we should also pay attention to this. It can be short jumper. If you don't want to short jumper this easy way, you want to fix the circuit, you need to measure the voltage of the G pole. If it doesn't sync with the drawing, you'll find the one under the G-pole and replace it. This is a bit more complicated. A present notice suggests that the short connection is a bit more realistic and faster. Do not consider this negative factor. This is first effect. Let's take a look at our second one, which acts as a high side and lower side MOSFET. Just now we talked about the application of level-to-level field tube. The other is connected to a large inductor. It works as an upper and lower tube. Let's take a look. The ground S-pole is the lower tube. This is charged and discharged by a large inductor, which is equivalent to the battery. This is a high side MOSFET. And our S-pole grounded is the lower tube. Then the two tools are turned on in turn to charge and discharge the inductor. And now low gas electricity from the inductor. These two tools are turned on in turn. The application of FET is more on the laptop. The high side MOSFET is turned on to charge the inductor. When fully charged, the lower tube is turned on. To control the discharge of the inductor, the two field tubes are turned on in turn. The high side MOSFET must be charging and the low side MOSFET must be discharging. So when we are pairing, we should pay attention to this point. CPU power supply circuit, RAM power supply circuit, bridge power supply circuit, charging circuit. They all adopt this power supply method, which is relatively easy to break. This inductor is generally not easy to break. The most easy to break is our FET tube, and the IC connected to the G-pole of the FET tube is also relatively easy to break. Let's move over and take a look at our IC. If there is no square wave in this G-pole, where is the G-pole? Let's search. In this position, take a first look. G-pole connected to the chip, right, this is the G-pole. DRV-H is connected to the G-pole, and H is the high side MOSFET, meaning high. L is for driving the lower side MOSFET. The output of this chip is 2, one is a square wave. The two field tubes are turned on in turn and cannot be turned on at the same time. One is to control the conduction of the lower side MOSFET, and the other is to control the conduction of the high side MOSFET. So when you lose this kind of circuit, the later circuit will talk about how this works. When there is no electricity on this inductor, it is possible that these two tubes are broken. It is also possible that our driver is broken. How to check the details? We'll talk in detail later when we talk about the major power supply. So today we focus on the application of this FET. We call this method switching power supply, also called PWM power supply. It is also the top priority of our later learning. Okay, the above is the way the MOSFET use it. Let's talk about how to measure this kind of 3-pin FET. Then its independent pin is a G-pole. The pin in the lower right corner is the S-pole, and the independent pin is the D-pole. That is the three polarities of the one appearance of the FET. We talked about it in the circuit diagram in the last class. Then when we measure the 3-pin FET, we only need to measure the value between the D-pole and the S-pole. Test the pros and cons. If you look at the multimeter, it also reaches the diode gear, because it has an integrated diode inside. If the red test lead is placed on the S-pole, the black test lead placed on the D-pole. This is a measure wave for the resistance, it's the N channel. You can see this is a multimeter display, usually around 300 to 800. As I said in the last lesson, if you can measure like this, adjust the direction of the test lead and measure it. It can be measured at least a set of value. You see there is no value in this way. Let's look at the other way around. Put the red test lead on the S-pole. Put the black test lead on our D-pole. If the value is measured in this way, it shows that the MOSFET is good. This pin, our G-pole is not involved in the measurement. In actual maintenance, we only test these two pins, D-pole and S-pole. If two positive and negative tests, there is no value or response both times, it is bad. This is measurement method for the 3-pin FET, whether it is N-channel or P-channel. Our FET also talked about what is N-channel and P-channel in the last class. Whether it is N-channel or P-channel, its measurement method is the same. But these two kinds of tools are not interchangeable. This is a 3-pin one. Let's talk about the 8-pin FET measurement. Then look at the second 8-pin FET measurement. The 8-pin FET, these pins are connected to the depot. Let's take a look. Let's take a closer look. These pins are connected, they are depot. So from below, the 3 pins are connected to the S pole. Let's put the buzzer gear to take a look. Our multimeter in the buzzer gear. The 3 pins are connected to the S pole. The first pin is a D pole, and our independent pin is a G pole. It is different from any pins. Then the tube may be broken down. Look at this tube, it won't work. Then the following FET is the same as this FET. You see, the connected pins are called D pole. The 3 pins are connected to the S pole. The thing that doesn't make sense with other pin is our G pole. Then the measurement of this kind of FET is the same. As long as measuring the D pole and S pole, whether it is an 8-pin or a 3-pin FET. Only the D pole and S pole are involved in the measurement. Take a look. I put the red test lead on the D pole. The black test lead is placed on the S pole. At this time, the multimeter is not set. Then let's take a look at how the 8-pin field 2 is measured. The same is true, the multimeter here's a dial file. At this time, put the red test lead on the S pole and black test lead on the D pole to see if there has value. 432 and 437. If the red test lead placed on the S pole and the black test lead placed on the D pole, at this time, black test lead is on the D pole and the 4 pins are connected to this position. Put the test lead firmly. 436. Place a red test lead on the S pole and the black test lead on the D pole. The one that can measure the value is the N channel. So if the value is measured in reverse, what is it? If during maintenance, put the black test lead on the S pole and the red test lead on the D pole. At this time, the measured value is the P channel. When we just measured it, let's take a look. If we put the test pan over 800, it will be regarded as invalid value. In actual maintenance, if the 2 test leads are, if there is no value twice or more than 800 both times, it is a bad MOSFET tube. We need to replace it during maintenance. This is a measurement method of the FET. P-channel and N-channel measurement methods are the same. Whether it is 8 pins or 3 pins, it is not interchangeable. P-channel and N-channel are absolutely not interchangeable. At the time, this kind of tube is relatively easy to broken. During maintenance, everyone should focus on learning to measure. For this kind of ironclad FET tube, it is relatively easy to break, but the measurement is more troublesome. You need to remove it to determine the G pole, D pole, and S pole. The measurement method is the same. Because it is more troublesome to test, we generally use a replacement method for direct replacement during maintenance. Find the N-channel replacement and fault can be resolved. In our later courses, we use the knowledge of the circuit to judge whether it is good or bad. Because the outside of the iron sheet is S pole, the inside is still G pole and D pole. So it's very troublesome to take it apart and measure the quality of this thing. Because we can take everything down and measure. So we'll talk about it in the course knowledge later. How to judge this thing with the knowledge of this current. Is it good or bad when connected? It's bad, just replace it.